What's going on, guys? This is your boy Astrum Sensei and welcome back to Let's Create a 3D Platformer in Unreal Engine 4. So in today's video we are going to be fixing the movement, we're going to be improving it overall, and we are going to be doing that by applying a Rootmotion system or animations. So what that means is that the movement of the player will be determined by the animation itself. So the animation is going to be what's moving the player. And of course, this isn't only one part. We are going to be adding the movement in this part and the jumping. So we're going to go through it all again through the animation blueprint and creating the blend space. It's going to be very simple, so don't panic. And after that, in the next video, we are going to be adding procedural leaning so that when the player turns, there's a little bit of leaning movement for the character. We're going to be doing that in the next part. We are also going to be fixing the crouching in the next part, but for now we are just going to be doing this so that we have like a solid game to test our levels in. So the first few minutes of this video are just me preparing the assets and converting them so that they have a root bone, just re-downloading all of the animations. So I made it a time lapse and I'm gonna add my instructions in the commentary. You're gonna see me doing things and I'm gonna tell you what to do. But after that, you know, I'm gonna start the tutorial doing it live with you guys in the engine. So I'm gonna leave a timestamp in the description, and I'm also gonna leave a list of all of the animations that you need to have to do this. But before we get started, please leave a like and subscribe if you are new to my channel, because that would really help. And you know, we're almost at 10,000 subscribers, so yeah, let's get there faster, please. And I want to super special thank my precious patrons who are supporting this series and this channel. I really appreciate it, you guys. Thank you very much. And yeah, let's go. So to be able to use Rootmotion for the animations, we're gonna have to replace all of those that we have downloaded earlier. We wanna download them with in place unchecked, because you know, you want the character to be moving actually when the animation plays. So I looked them all up again in mixamo.com and I replaced them all actually, most of them I mean, because you know, the old ones I chose weren't that great, so I just looked up new ones and I liked them. I also added a walking animation that we can play between idle and running so that it's less snappy. When you are transitioning between idle and running, there will be a walking now, and you know, that will just improve things a lot more. So yeah, please do the same. Another addition I made to the old version is the diagonal animations. Those are, you know, jogging for left forward and forward right, and backward left and backward right. So now when you press W and D together while running forward, the player will play the diagonal animation, and that will just make it much better. So next, just add them to a new folder and open Blender. And if you don't have Blender or you don't know how to use it, it's very simple and you don't need to know how to use it to do this. So just download Blender and open it. So what we're gonna need Blender for is basically something very simple. The Unreal skeleton has something called a root bone in the skeleton, and the Mixamo rig or skeleton doesn't have it. And to be able to use Rootmotion, we really need a root bone. So we are going to download a plugin for Blender, which will add the root bone to our character and our animations. And that's why we are going to convert them before putting them into Unreal Engine. And now that we've downloaded the animations without in place checked, we can use them for Rootmotion, which I'm going to show you how later. So you want to go to Google and download Blender Rootbone plugin and look for the first search result, which is going to be a GitHub link. So just open it, and over there should be the download page. If you press on the green button which says code, there should be an option to download zip, and then in the Blender you want to press edit preferences and choose add-ons, then install, and choose the zip file that you've just downloaded and select it and just press the check on it. In the plugins here, there should be the mix ammo converter. For the input, you want to choose where your files are located, and for the output, you want to choose the folder where you want to place your files that will be created when you convert them. So the converted one will be in the output, and in the input, it's gonna be the ones that you want to convert. So next, click on Advanced Options, turn off Use Z, and turn off Apply Rotation, and you want to ignore Leaf, so just check that. Also, we want to use Unreal Engine bone names, and we can, activate this by checking off the one over it. And in the hip bone name, you want to go to Unreal Engine and check out the mannequin, what the hip bone is called, because we want it to be accurate to this one in case we ever want to retarget animations from the marketplace, or we decided that we're going to retarget the skeleton to be similar to the one that's the Unreal skeleton. So just look up the hip bone. It's actually the pelvis, which is the one at the top under the root bone, because if you notice in the original Mixamo files there is no root bone. Turn off the advanced options and click on batch convert, and that should take a little bit of a while if your computer is crappy like mine. But hey, even if it is, it's just less than a minute. So if it's more than a minute, then your computer is like super crappy. Get a new one. So now that we are done working on the assets, we are gonna import them into Unreal Engine. So this is where the tutorial part of the video actually starts. Okay, so now that we are done preparing, we are gonna just import everything into the engine and make it work. So the first thing we're gonna do once we have opened our engine is we are gonna go to the characters folder where we've imported our chibi boy, and we made him a folder. Of course, here he is. We are gonna replace him, but first we are not gonna delete him. We need the character in case we need something from it. So we're not going to delete anything unless we are sure that the new version works. So I'm just going to create a brand new folder, and I'm going to call it old version. Of course, we can't use spaces, so just call it old version. And we are just going to drag them all into it and drop them in there. Actually, no, we're going to keep the material here. We need it. And we're just going to move them. And then what we are going to do is we are actually going to import the brand new character model. So here are the assets that we've created. First, you want to import only the character model. So just drag him in here and drop him. And there should be a few options. First, you don't want to choose a skeleton, and you just want to keep these two checked, skeletal mesh and import mesh. Also, import animations, we don't need it. We have import uniform scale. I actually made it 25 because there is no, like if you place it on the original, which is 1, this character particularly is very, very small. So to make him the same size as this, because I've scaled him up, if you remember, in the first part, so we don't need to scale him up. If we make the import uniform scale 25, so he's going to be much larger than his original size, but hey, that's just what we need. So just click import, and that should add in the character. And oh, I put him in the wrong area. Okay, we're just gonna move it to the chibi boy folder, and we have the old material. We are just gonna apply it on this character, so just drag it and drop it in here, and that should just work. And if you drop him here, you can see that he works. And when we moved this stuff to the old version folder, the animations folder remained, it's empty. So we're just gonna place the new animations here. So if you go here and select all of your animations and just drop them into the engine, that should just start importing them. So first, you want to choose the new skeleton that you've just imported. Please make sure that you don't choose the old one. Then you want to not import skeletal mesh, or actually no, not import mesh. And what else? Yeah, import uniform scale, keep it at 25, and just import all. And you can see that they've imported perfectly. Now we are going to work on the blend space, the animation blueprint, and finally the blueprints itself for the character. So first thing we want to do is the blend space. Just right click, animation, blend space. This time we are not going to use a one directional blend space. We are just going to use a normal blend space and choose the brand new model. We're going to call this idle to run blend space, and we are going to open it. We have horizontal axis and vertical axis. So this is the speed to the side. So we're going to call it speed side or side speed, whatever you want. The minimum is going to be -1, because for the Rootmotion animation system or the Rootmotion movement system, the speed is not going to be determined by how fast the character is walking, but instead it's going to be determined by how much the player is pushing the analog stick or the movement stick of the controller. So if the player is moving it only slightly to the side, it's going to be less than to the back, it's going to be to the side, it's going to be slightly less than it's going to be slightly less than -1, and if they are moving it to the forward, it's going to be 1, or slightly, it's going to be between 0 and 1. I don't know if I've explained it properly, but I hope I did. Then we have the number of grid divisions. We're going to keep it the same. Interpolation time, which is how fast the animation blends, it's going to be 0.1, which is faster than the higher numbers, so 0.1 is just fast enough. Then we have over here speed forward, so just type in speed forward, and the same goes for this. Forward is going to be -1, the minimum axis, and the maximum axis is just going to be 1, and the interpolation time is 0.1. Now we are going to place the animations in the actual blend space. Idle goes to speed side 0, speed forward 0. Walking is going to go 0.5. So if you press shift, you can see that the animations are playing. Then after the walking, we have the running. And of course, there is an issue here, which is that the character just keeps moving backwards. So you want to go to the content browser and select them all. Then you want to right click and go to Asset Actions, Bulk Edit via Property Matrix, then go to Animation, and we are just gonna enable the Rootmotion, no, not animation, Rootmotion, enable Rootmotion and anim first frame instead of reference pose. So just close this, and the issue should be fixed if you go back to the blend space, as you can see. Now we are going to put the walking backwards at -0.5 and the running backwards at the -1, as you can see. This one's a little bit too fast, so I'm gonna change the rate scale to be 0.8. This is how fast the animation plays. It can be even slower, 0.5. No, that's a bit too slow, 0.7. Yeah, that's great. Now we are going to work on the sides. I actually added left strafe walking and right strafe walking to the animations that I've downloaded, and I didn't talk about it in the previous few minutes of the first few minutes of the video. I didn't mention it, so yeah, I added this later, but yeah, it just improves the quality. It's not really that necessary. And we are going to be adding the diagonal jog forward. The jogging is going to be actually in the corner all the way over there, because he's not working. Actually, I'm not sure. Yeah, let's just keep it there. And we have the other one, which goes to the other side. Then we have the jog backward diagonal. We're just gonna place it. Oh, not on this side. It's gonna be there. And the other one is over there. Yeah, this is great. We are done with the blend space. Now we are going to be working on the animation blueprint. And yeah, this is the old animation blueprint. We are going to need it for reference. So just move it to the old version folder and create a brand new one here. Animation blueprint. Choose the new skeleton, not the old one. And just call it anim BP. Yeah, I'm just gonna add the chippy boy name. And we're gonna open it. And we are also gonna open the old one because we want to copy a bunch of stuff from there. So if you go to the old version over here and open it, you can see that we have a few stuff that we are gonna need. So first of all, I'm gonna copy this entire thing. Actually, no. Okay. Set speed variable, we are not gonna need this. We're just gonna copy this entire thing and paste it in the new event graph of the new blend space, or the new anim BP. And if you compile, there should be a few issues. First of all, crouched and dodging and isn't there are not variables over here, so we're gonna need to create variables for them. But before we do, we are gonna create the variables in order. So we need the forward speed and side speed variables. Just create them. And they need to be floats. Then to create those red variables, the booleans, very easily, you can just right click, create variable, right click, create variable, and right click, create variable. And if you compile, the issues should be gone. Of course, it's not working yet because we didn't do anything in the anim graph, but so far this is what we need to do to get rid of all the issues. And to organize it, I'm just gonna place everything there. And yeah, this is just the correct thing to do right now. Now we are gonna go to the output pose, or the anim graph, and we are gonna drag in our new blend space so that we can test it. And if you go here and connect the variables, speed forward and speed side, and compile, it should work. But if you press play, it's not gonna work. Oh, we first we didn't even add the character to the blueprint, to the player blueprint. So we're gonna go to the blueprints here, and if you go to BP base, you can just click on this character and replace him with the new one. And of course, the new one is huge because I've scaled the old one up over here instead of while importing. So we're just gonna click on the yellow arrow, and that should just make him work as usual. And as for the animation blueprint, choose the anim class for the brand new blueprint, which I'm not sure which one. Yeah, it's the second one. It's the same name, so I made a problem with that. Now if we play, you can see that it's not working. And that is because we didn't actually give it the player speed in any way. So we're gonna do just that right now. Now to do that, what we need to do is we need to create a blueprint interface so that we can connect between the anim blueprint and the normal blueprint and communicate the speed and how much the character or the player is pushing the stick. Of course, I'm not playing with a controller, so it's not gonna show up like the walking by slightly tilting the stick or just moving it up completely and making the character run. We can't test that right now because I don't have the controller connected, but if I did, it would work. So next we are gonna go to the blueprints here and create a blueprint interface, and I'm just gonna call it player interface. And we are going to create a brand new function here. I'm going to call it get movement input, and we want to create an output for it, which I'm just gonna simply call movement. The variable type is gonna be a vector, and just compile and close it. And if you go to class settings here, you can add the interface to the player blueprint. So what did we call it? Player interface, and compile. Now if you go over here, we have the interfaces, get movement input, and the movement should be here. We should add the movement by connecting all of the values that we need to this one. But first, let us apply the interface to the animation blueprint also, because we also need it here. So just go to class settings, add player interface, and compile. Now over here again, back in the BP base, in the interface here, over here for the get movement input, what we are going to do is we are going to get the move forward, or just type in move forward, and move right, and then we are going to multiply them by a float, or by a vector, sorry, vector by float, and also same goes for this one. Then we are going to get the forward vector. So to do that, just type in get, first you want to get control rotation, and then split struct pin over here, and from this one get forward vector, and then you want to get forward vector, and you want to get right vector. Then we are going to split struct pin and connect them to the Z, and this is going to be what we are multiplying the get move forward with and the get move right with. Then we are going to add them up together, so just plus vector, and actually no, it should be like this, that's more organized. And finally we want to normalize and connect it to the movement. And if you compile now, you should try it, and it's still not gonna work because we didn't give the info to the event graph of the animation blueprint. So over here in the animation blueprint, what you want to do is you want to get the forward and right vector and make them the forward speed and the side speed. And to do that, we are just gonna, over here we have try get pwn owner, we are just gonna do it like this and type in get right vector and also forward vector. Then you want to dot them twice. Like this. Then after we finish all of the stuff over here at the, after the event blueprint update animation, everything goes finished over there. Actually the order doesn't matter too much. Then from the last one you want to get movement input, which is the new function in the interface that we made, but actually we're not going to get it from here. We are going to get it from the try get pwn owner. So just type in get movement input, and that should just work. Then connect it to the last one, and the movement should be the dot over here. Just connect it there to both dots. Then we are going to set forward speed and set side speed and connect them like this. And just connect the values, the floats of the dots to the set of the both values, and if you compile and press play, I think it should work. Yeah, it works. And as you can see, it's a little bit smoother than before, and the jump still doesn't work. So I think the character is a little bit too slow. We are gonna make them a little faster by going to the blend space of the animations. And this is just the way to change the character speed now. Just go to the rate scale of the running animation, and I'm gonna change it to 1.4, and that should just make it faster. And with the Rootmotion system, if the animation is faster, the character is just automatically faster because he moves when the animation moves. And as you can see, it works great now, and when you turn, it's looking smoother because of all the directions that we've added. I like it. And we can quickly make the jump work if we want. Over here are the animations that I've downloaded and converted. I'm just gonna drag them in here and drop them and choose the skeleton, the new one, of course. Let's make sure, yeah, it is the new one. Turn off import mesh and make sure the uniform scale is at 25. Then I'm gonna import all, and they should be over there. I'm gonna select them all, asset actions, bulk edit via property matrix, and enable Rootmotion. The Rootmotion root lock is going to be the anim first frame. Then we are just going to go back to the animation blueprint and quickly add in the jumping. So over here we have the anim graph. Oh no, this is the old version, and over here is our anim graph. So we need to have the idle run blend space be inside of the anim state that we've made earlier, but it got deleted because, you know, all of that replacing stuff. So just type in new state machine, and this one is going to be called idle dash or slash jump, and connect it to the output pose. Then we are going to cut everything over here and enter the idle jump state and create a new state, which is called idle slash run. And the new stuff, or the blend space, should be connected to this one. So this is the default state of the character. Then we want to change the default state to have jump loop, jump forward, jump start, and jump end, which we have imported. So what we are going to do is we are just going to drag out of here as we did in the jumping video, add state. I'm going to call it jump start. Then we are going to create a brand new state, jump loop, as you can see. Then the last one is going to be jump and, or of course I forgot, yeah, like this, jump and we want to have a space between them. Then connect it back to the idle run, and now we want to add conditions for transitioning into the jumping animations. But first, let us add the animations as they are. So we have the jump start, just connect it like this, and make sure to turn off loop animation over here, and compile jump loop, which is over here. You can just break them from here, connect it like this. And for this one, you don't want to turn off the loop animation, but it's better if we made the play rate slow. So I'm going to go with 0.3 so that it's now very snappy, because the animation is quite bad. So just go back and finally do the jump end. And for this one, you also want to turn off the loop and compile. And now there should be an issue where there's nothing inside of these conditions for transitioning into these other states. So we're gonna enter them and add in the conditions. And to find out what we need to add, we are gonna go back to the old version and check out what we did in the previous jumping video. Yeah, we just added the jump is in air condition, and for this one we have the time remaining jump start, which is less than or equal to, or without equal to, just less than. So for this one we're just gonna check is in air. If we are in the air, the condition is gonna be jump start. Then over here we are gonna check if the time remaining for the animation is less than 0.1. So just type in time remaining ratio jump start, and you can't copy this part because it will not work. You just have to do it all over again. Then you want to transition into the jump end. We're going to check out the old version, which is not is in air, so just copy it and paste it. Then from jump end to idle, we're gonna go and check what else we did. Time remaining jump end and less than. So just bring it in here and do it like this. Then type in remaining and compile. And now if we press play and jump, the jumping animation should go back to working. Now if we want to make the jumping a little bit better, we can either change the gravity or the jump Z velocity, because it's not very good. So that's going to be the last thing I do in this video, because this one needs a lot of adjusting and it's just not turning out good actually. So jump max hold time, I'm gonna make it 0.1, and we have the jump Z velocity. Where is it? Actually it's in the character movement. We have gravity scale. We're gonna make it 4 maybe. You know, things have changed now. Yeah, that's a little too heavy. We're gonna bring it back to 3 and try it again. Jump Z velocity, I'm gonna make it 420, and I'm gonna decrease the gravity into 2. And if we try it again, I mean, yeah, it's not that bad, but 420 is a little bit too low. 520, and the gravity is going to be 2.5. Yeah, we're going to bring back the jump max hold time to 0.2. Yeah, this is fine. The jump Z velocity is gonna be a little bit lower, so maybe 460 would work. Yeah, I'm satisfied with this for now. That's just fine. What we need to do is we actually need to make the capsule smaller because it's much wider than the actual character. I'm just gonna change the capsule radius and make it much smaller and kinda shorter. And then I'm gonna bring the character up a bit. No, that's too much. Like this. And that should fix the issue where we can jump, we can stand in the air, because the capsule is just very wide. It was very wide, so we fixed that. And the camera, I want to make it a little bit farther. So for the target arm length of the camera boom, I'm gonna make it 500 and play, because that's how things are in platformers. They're never close with the camera. Yeah, that's better. And yeah, that should be it for the part, guys. If you've enjoyed it, please make sure to leave a like and subscribe for more Unreal Engine tutorials and Unity tutorials. Hope you're looking forward for the next part, where we are going to be adding procedural leaning, and I will see you next time. Take care, have a great day, and bye.